Now we see the second method of finding out the optimal solution of an LPP, and that is called as isoprofit or isocost line method. Now here the steps till finding out and shading the feasible region are same as we did in the corner point method. So after shading the feasible region, now we use this second method to get the optimal solution. Now one point regarding the nomenclature, that is, if it's a maximization problem, then we use the wording isoprofit line, and if it is minimization problem, then we use the wording isocost line, right? Okay, now what is this method? Let's first consider the isoprofit line method for a maximization type of LPP. The LPP is mentioned in a formulated manner in front of you. So we have to maximize this objective function z subject to given constraint, right? Now what we have to do is we have to consider some point inside the feasible region. We are free to choose any point. Alright, so let us go to the next slide and see. Let us consider some point here, say 5,5, which is inside the feasible region, and we have to evaluate the value of the objective function at that point. Okay, so if I consider the point 5,5, clearly if we substitute it in the z, we will get z is equal to 900 into 5 plus 1100 into 5. So that turns out to be 4500 plus 5500, which in turn is 10,000. So therefore here we get the expression 900x plus 1100y is equal to 10,000. Now this particular equation represents a line which is called as isoprofit line. Okay, it is not, of course, any of the constraint line. It's a line that has been constructed using the expression in the objective function. Alright, so we plot that line. Alright, we know how to plot a line. Take any 2 points and we know how to plot it. So let me draw it in a yellow color dashed manner. Alright, now after drawing this, we call this as initial isoprofit line. Initial isoprofit line. Alright. Now after this, we have to perform a specific operation. Let us see what that particular operation is. It's mentioned in the next slide. So if it is a maximization type of problem, move the initial isoprofit line parallel to itself and away from origin. So here you see that's the initial isoprofit line we have already drawn. So let us move it parallel to itself and away from origin. So in this way you can see that it is going to cut through the entire feasible region. Now in doing this, a point will come, a stage will come where it is passing through the last point of the feasible region, and after which it is going completely out of the feasible region. Alright, so we have to find out what is that last point of the feasible region through which the isoprofit line passes before it goes completely out of the feasible region, and this particular point is precisely the optimal solution of the LPP, and this is the same point which we got in case of the corner point method also. Alright, so here that's the benefit of isoprofit line method, that we directly get what is that particular vertex which is the optimal solution. Of course we have to get the coordinates of that particular point by solving the equations of two constraint lines simultaneously, but at least we got to know which is the optimal solution using the isoprofit line. Right. Now in case of the isocost line, that is whenever you have minimization problem, there is only a minor change, and let us see what that change is. So here as mentioned, for minimization problem, move the initial isocost line parallel to itself but towards the origin. Right? So let us visualize how it will happen. Here also we take any point as we wish in the feasible region, and then we draw the initial isocost line. Okay, then let us move it parallel to itself and towards the origin. So as you can see, it is moved towards the origin. It is passing through the feasible region, And as you can see now, the last point through which it passes is point B. Right? So this represents the optimal solution for the minimization problem. Right? So in case of minimization, we have to move the ISO cost line parallel to itself but towards origin, and in case of maximization problem, we have to move the ISO profit line parallel to itself but away from origin. Right? So with this, we get the solution of the given LPP. It may happen that instead of one vertex, there are more than one vertices also through which the ISO profit and ISO cost line may pass, but that is considered as a special case and we will deal it separately.